Okay, let's go over this calculations of solutions practice. The first thing you need to do is calculate the molarity, capital M, of the following. Right? Remember that molarity is moles of solute over liters of solution. So these are the units that you need to have, top and bottom. Okay, number 1. 1 mole of potassium fluoride is dissolved to make 0.1 liters of solution. Simple enough, you just take the 1 mole of potassium fluoride over the 0.1 liters of solution, and you get 10 molar. Alright. Number 2, 1 gram of potassium fluoride is dissolved to make 0.1 liters of solution. Well, 1 gram is not the unit that we need. We need to convert that into moles using the molar mass, which is 58 grams. And then you need to multiply it by the inverse liters. Okay, this is something that trips up students pretty often. Typically we're used to seeing fractions with a number 1 below because it doesn't change anything. But in this case, we do want the liters to be on the bottom, so you can just flip the ratio and have 1 over 0.1 liters. Okay, after you do this, you can see that the grams will cancel, moles does not cancel with liters, and that's a good thing because the molarity unit is moles per liter. So 1 across the top, divide by 58, divide by 0.1 is 0.17 molar. Number 3, we have 1 gram of potassium fluoride is dissolved to make 10 milliliters of solution. It's a similar process here, but we have to do one more conversion. So we have 1 gram, divide by the molar mass, divide by this volume unit, which is 10 milliliters, and then we need to convert this milliliters to liters. And we know that 1,000 milliliters is 1 liter. Okay, and then you get 1.7 molar. Number 4, 952 grams of ammonium carbonate are dissolved to make 1.75 liters of solution. Okay, what is the molarity of that? Well, we need to take the grams and convert it to moles using the molar mass, and then we need to include this volume unit on the bottom. 1.75 liters is what we're given, so we place that on bottom, and we have the units moles per liter, and that's 5.67 molar. Alright, number 5 down here, 9.82 grams of lead 4 nitrate are dissolved to make 465 milliliters of a solution. Again, we need to think about what we're given and what we need to go to. So grams and milliliters, both of those need to be changed at some point in this calculation. So let's start with what we're given, 9.82 grams. Convert that with the molar mass, 455 grams of lead 4 nitrate is 1 mole. Multiply that by the inverse of 465 milliliters to get it on bottom, and then multiply that by 1,000 milliliters per liter to convert the volume unit to liters, and you end up with 0.0465 molar. Alright, this one's a little tricky just because you need to think ahead with the units, right? But you can see that moles and liters do not cancel, and that is a good thing because that is the unit for molarity. Alright, on the back of this page we have dilutions, and what you need to know for these is this equation, C1V1 equals C2V2. So concentration 1 times volume 1 equals concentration 2 times volume 2. Alright, so number 1. If water is added to 175 milliliters of a 0.45 molar potassium hydroxide solution until the volume is 250 milliliters, what will the molarity of the diluted solution be? The trick to these is looking for words, keywords, in the question itself to tell you what is what, okay? So if water is added to this number for the volume, you know that this is going to be the original volume, and this is going to be the original concentration because it says of A, so those are together. Until the volume is 250. Until the volume shows that this is going to be volume 2, the final volume. And what will the molarity of the diluted solution be? That tells us that we're looking for the second concentration, which is C2. Alright, so the setup is 0.45 molar times 175 milliliters equals C2 times 250 milliliters. The key to this is to make sure that the units on either side match. Okay, it doesn't matter that this is not liters because milliliters and milliliters will cancel. So all you have to do here is divide by the 250 and C2 is left alone, and it ends up being 0.32 molar. Okay, all of these are pretty similar. Let's move on to number 2. The setup is the same. 9 molar times 450 milliliters equals 0.075 molar times V2. We're looking for V2 here. Once you do this division across, V2 is left by itself, and it ends up being 54,000 milliliters, or simply 54 liters. Okay, number 3. If 550 milliliters of a 3.5 molar potassium chloride solution are set aside and allowed to evaporate until the volume of the solution is 275 milliliters, what will the molarity of the solution be? Again, you need to look for keywords here. Okay, if it's allowed to evaporate, this is almost the opposite of a dilution, right? So it's going to become more concentrated. So you should expect C2 here to be greater than C1, which it is. All right. The setup here is pretty simple. C1 V1 equals C2 V2. You divide V2 over here, and you're left with C2, which is 7 molar. Number 4. Okay, this one's a little bit trickier. If 45 milliliters of water are added to 250 milliliters of a 0.75 molar K2SO4 solution, what will the molarity of the diluted solution be? So we're looking for the molarity of the diluted solution, which means this is C2. Okay. We need to realize that 45 milliliters are added to 250. So 45 plus 250 is 295, and that is V2. That's volume 2. The rest of it goes on the side with C1 V1, and C2 ends up being 0.64 molar. Okay, that's a more realistic problem. And lastly, here's another realistic problem. How much water in liters would need to be added to 750 milliliters of a 2.8 molar hydrochloric acid solution to make a 1 molar solution? So what we want to do is make this into a 1 molar solution, but we need to find out how much water needs to be added first. So we set it up, C1 V1 equals C2 V2. Of course, we're looking for V2 because we need to find out how much water is added. So we solve for V2, and that ends up being about 2.1 liters. However, this is not how much water is added, that's the total V2, right? So we take V2, which is 2.1 liters, and we set it equal to the original solution volume added with the water. Okay, so this whole thing has to equal 2.1. So 2.1 minus 0.75 would be our water added, and that is 1.35 liters. Okay, so it's really important to pay attention to the question and to read it carefully, because it will give you hints along the way telling you how to set these up. Anyway, let me know if you have any questions about this. I'm always available via email, or you can come in for tutoring. Thanks.